Welcome back. Last time, we introduced basic slicing and discussed how it takes consecutive parts of the array. This time, we're going to loosen up that definition and introduce stepwise slicing. As the name suggests, stepwise slicing represents slicing where we don't take consecutive values, but values which are a certain distance apart. This distance is the step. In this lesson, we're going to learn how to use it. As always, we'll start by defining the array we intend to use. In this case, this is a 3x5 matrix. So, to avoid confusion with the 2x3 matrix we used in the last lesson, we'll call it matrix B. All right. In the previous lecture, we learned that if we write colon, comma, colon within the square brackets, the slice is actually the entire dataset. Once again, this is because the default values for the start and end of the slice are the start and end of the array. Hence, if we don't specify them, we take the entire array. Now, we can add another colon for each dimension of indices. The new syntax is the following. For a given dimension, the values on either side of the first colon represent the start and the end of the slice, while the value after the second colon represent the step. And this is applicable for every index value on each side of the comma or commas that have been used within the brackets. By default, this is set to 1, so that we don't unintentionally skip any rows or columns. However, let's see what happens if we set it equal to 2 for rows. We get a 2x5 array, which contains the first and third rows of the original matrix. In other words, we started at the row with index 0, and then jumped to the row with index 2. Therefore, we're slicing every other row. If we instead set the step for columns to be 2, then we'd expect to slice every other column, right? Let's see if that's the case. We see a 3x3 array containing the first, third, and fifth columns of the original variable, matrix B. Thus, the step part of slicing works identically for each dimension. Let's see what happens when we set the steps for both rows and columns to 2 simultaneously. The result is a new array, which takes every other value of every other row starting from the first. To put it differently, we are interested in every second value in the rows, as indicated after the colons here, and we do that for every second row, beginning from the first one. Hence, we're taking the first, third, and fifth values of the first row, and then the same values of the third row. It's because we're starting at the value in position 0, 0, then moving to position 0, 2, and so on. We do this until we're done with the first row, which in our case is position 0, 4. Then we move to position 2, 0 and go through the third row in that exact same manner. That is, in our example, we'd go through positions 2, 2 and 2, 4. Great. So, the step argument can be any integer, positive or negative, but it can't be 0. Of course, that is because we would not be traversing the array at all, and we would be stuck at our starting position, 0, 0 in our case. However, negative steps can be a bit tricky, since we're essentially going through the array backwards. Let's change the step for the first dimension to -2 and examine the output to see what we mean. The first element of the new array is the first element of the last row. This points out that by default, we're starting from the bottom of the matrix and moving up. So, if we set -1 as our entry point for the rows, we would get the exact same output. Do you agree? Nice! To further elaborate on how we obtain this array, you can consider that our starting position is now 2, 0, and after we complete the entire last row, we'll move 2 steps back to 0, 0. This is easier to see if we have more steps, so let's change the row step to -1. Now, we have 3 lines, so it's easier to spot that we're starting from position 2, 0, going through the row before jumping back to 1, 0, and repeating the same process until we eventually reach the origin. All right. Of course, we can use negative steps for the columns as well. We'll leave it as a homework exercise that you can do right after you finish watching this lecture. Great! Before we move on to studying other topics, there is one last type of slicing we need to discuss: conditional slicing. In the next lecture, we'll talk about what conditional slicing is and how we can use it. Thanks for watching!